Hello, my name is Darren Kosinski. I'm an engineer on the FireMonkey team at Embarcadero. Today I'd like to share with you some of the new things that have been added to the FireMonkey framework over the past year or so. We've continued to enhance our support for Windows, Mac OS X, and iOS, and in Rad Studio XE6 we added support for Android devices, including phones, tablets, and Google Glass. These are a lot of platforms to support, with a lot of differences in the look and feel between them. One of our top goals over the past year has been to find ways to make it easier for you to write apps that can target all of them. We've added platform default behaviors that let controls change their size and position based on the device they're running on. We've created a new variant of form inheritance that we call Delta Streams that can apply modifications to a form based on the runtime device. This is the core technology that is at the heart of the Fire UI designer. All of these concepts come together in a new transforming supercomponent called TMultiView. We've also added some new platform services to make it easier to save and restore application state and to write diagnostic information to system logs. For edit controls, we've added an option of using a native presentation of the control for iOS. This provides greater performance and fidelity on iOS while still allowing the development of multi-platform code. There's a lot more that's changed too, but this is what we'll have time to cover today. Let's take a look at these in a little more detail. Between iOS, Android, Windows, and Mac OS X, many controls have different sizes. In Rad Studio XE7, we wanted to introduce the idea of an abstract size so that a component could automatically get the right size for the runtime device. We introduced a new size property on the FireMonkey T control. Instead of just being a collection of scalar values, the size property is a T-persistent object that has a property called platform default. When this is enabled, it makes the component automatically resize based on the runtime platform or the platform properties of the view selected in the designer. The old width and height properties still exist, but they set and retrieve their values from this new T-control size object. When you drop a new component on the form, the platform default property is set to true. When you resize the component, either in the designer or in code, it automatically turns off the platform default setting so that the component keeps the size that you designed on all the platforms. We also added a new value to the tab position enumeration for the T-tab control. It's called platform default. For new tab controls, this is the default setting. When your app is run on most platforms, this setting causes the tabs to be positioned at the top of the tab control. When the app runs on iOS, the tabs will be positioned at the bottom of the tab control. Let's take a look at this. So this is just a FireMonkey form with a tab control, a few tab items, and a button. Let's look at the button. If we look at the property inspector or object inspector, see we have this size property now, which is of type T control size. It has the height and width, and it has the platform default setting, and it's set to true. Now let's try adding a, let's add say an Android 5-inch phone view onto this. So a few things have happened here. Of course you get the Android appearance, but if we look at the button, let's come and look at the size again. You can see that the height and width have changed. Platform default is still set to true, but this is the standard size, the default size of a button for the Android platform. And if we do something, let's add a, say a 4-inch iPhone view. And now a few other things have changed here. The button, since there's no outline, it's a little harder to tell the size, but if we look here, we can see that it's also different from the master view, but it has platform default set to true. But another thing that's happened is you see that the tab controls, the tab items, have moved to the bottom of the tab control. If we come back to the Android view, you see they're at the top. the iPhone view, they're at the bottom. And if we look at the tab control, see the tab position property, and you see that's set to platform default. Let me come back to the master view, and on the tab control, so you can still, of course, lock it to top or bottom position as you like. But if you set it to platform default, which is standard for a new tab control that you drop on a form, then it will automatically change the view based on the runtime platform or the view that's selected in the designer. So let me show you a little bit. Let me add another button here to the form. So this is a new control that was dropped, which of course means the platform default setting is true. But now let's resize it. Say this button, I want this button to be a large button for whatever reason. And if we look, you see that the platform default is now true, and the size is set to how we sized it in the designer. And if we come over to the Android view, you see it's also maintained that size, the size that we defined for it. Again, platform default is set to false. If we come back to the master view, and if this resizing was an accident, if, for example, we clicked on the corner and dragged when we didn't really mean to, we can come back here, set the size back to platform default, and it will resize the control to the default size. And if we look here on the Android view, you see that it's also been changed back to the default size. Now the platform default is set to true. So that's a look at some of the platform default behaviors that we've added. It lets you design a form and have the control size to what's appropriate for the runtime platform, and also to reposition the tab control, the tab items, based on the runtime platform. So in that last demo, you saw a little bit of the Fire UI multi-device designer. And I'm sure you've seen some of the other videos and demonstrations of Fire UI. You saw how you can add views for different devices to a form. And I want to show you now how this works behind the scenes and some of the things it means for you as a developer. For a long time, Delphi and C++ Builder have had a feature called form inheritance. Form inheritance allows you to create a new form which inherits all of the components, properties, and events from an existing form. We've adapted the form inheritance technology to create a mechanism called delta streams. With this mechanism, a form is composed of two separate streams, a master stream and a stream which contains the differences or deltas from the master. Each of these delta streams are stored in their own FMX form file and referenced in the unit as resources. A unit can have several delta streams associated with it, and the runtime will use device detection logic to pick the best one to use. One key difference between delta streams and form inheritance is that there's just a single form class that's used for all of the views. So that means all of the device views will have the same set of components on them. But you can choose to show and hide some of them on different views. It's probably a little easier to show this in code, so let's walk through a demo. So here I have a project that has a FireMonkey form. I've defined a couple of views for it, an Android 5-inch phone and an Android 7-inch tablet. Let me add a few controls here. Let's add a couple buttons and an edit, say. So if we look at the form file here, this is a form file like what you would always expect to see. You have the form object, we have button object for the first button, the second button for the edit. We go to the views, so the 5-inch, and we have the edit, the two buttons. Let's look at this form file. This is a lot different. There's only a few things listed here, but it's shown as inherited. And these are the differences between this view and the master view. The client height and client width have changed, and also the flag that it's the master view is also set to 0. And similarly, on the other one, Android 7, it's also an inherited view. Now let's say, for example, that button 2 does not apply for an Android 5-inch phone. For whatever reason, it activates functionality that does not exist on this form factor. So let's make this button 2 hidden in this form factor. Select button 2. Make it invisible. Now if we view as text here, so we have inherited button 2 visible as false. This is the delta, the difference from the master form. This is very much like what you would expect to see with an inherited form. So how does the runtime know that these different views exist? Let's take a look at the code. You notice there's only one code tab for all of these views. The views are defined by this resource block. So you have this resource. This is for the master form resource. This loads, in this case, it would be unit1.fmx. This has existed since the beginning of FireMonkey. But then there's these two extra ones that have these funny names on them. These funny names are actually very specific names that are defined in the runtime. They're defined in this unit, system.android devices. There's a similar unit for iOS too, system.iOS devices. But you see we have all of these funny names defined, and these all correspond to different form factors. And not all of these are in use right now. We've reserved these names to handle new devices that may come out in the future. Different Android manufacturers come out with new devices. What we've done in this release is we've defined 6 of these. Let's close this up again. And these 6 correspond to what you see in the designer as the views that are available. Here we have 1, 2, 3, 4, 5, 6 different Android devices. So since the unit defines, in this case, these 2 delta streams, how does the runtime figure out which of these to load? Does it load all of them? Does it just load one of them? Well, let me show you that a little bit. When the form is created, one of the methods that's called is this new method called getDeltaStreams. This is defined on Common Custom Form. And what getDeltaStreams does is it calls a behavior service called getDisplayMetrics. And that returns information about the device that the application is being run on. And so it returns information about the physical screen size, the pixel density. And we take that information and we pass it to this runtime method, selectDevices, tDeviceInfo.selectDevices. What this method will do is it will return to us an ordered list of these 6 devices that we've defined It rearranges them and puts them in order with the best match at the top and the worst match at the bottom. So when the form is loaded, we get this ordered list of the best matches of devices. In other words, the best matches of possible delta streams that may or may not exist. And then we send that ordered list to this method, readComponent delta resource. This is a runtime method. It's in system.classes. And this looks for these resources. It takes that ordered list and it looks at these resources that have been linked into this unit, and it tries to find the best match. So if you're running this form, this application, on an Android 5-inch phone, chances are that it's going to match this resource, which is the best resource to match the phone, and you'll get a screen that looks like this. If the device was, say, a 5.5 or a 6-inch phone, which one would it match? Well, it would depend on the screen density. It would depend on how it best matches, what the closest match is to which of these form factors. If you have a 6.5-inch phone, for example, it would probably match the 7-inch tablet more closely. A 5.5-inch phone would probably more closely match this one. So that's how the runtime determines which of these delta views is going to be displayed. The delta views, the resources for the delta views are listed in the unit as resources, and then this mechanism, select devices, which is called by the form's getDeltaStreams method, determines the best match and tries to load the right resource at runtime. And that's how the delta stream mechanism works. The platform default behaviors and the use of device-specific delta streams all contribute to our goal of making it easy to develop an application that runs well on any device. One thing that's missing is a device-appropriate way to provide navigation within your app. On a phone, navigation is typically handled with the use of drawers that slide out to reveal options that are really effectively menus. On a larger tablet or desktop app, this is often handled with dock panels. Sometimes these panels contain lists. Sometimes they're buttons. Our answer to this, our solution for this, is a new component that is called TMultiView. At its base, TMultiView is a container control, kind of like a panel. It can hold individual controls like buttons, edit fields, list views, or it can host other containers like a tab control. The display and drawing of the panel is abstracted to a presentation class. And we've defined presentation classes for the most common types of displays. We have a presentation class for a drawer, which can either overlay the existing content or push the content aside. We've defined a presentation for a docked panel, and it's also possible for you to develop and register your own presentation object and use that if you don't want to use one of our predefined ones. I think TMultiView is probably best shown with a demo, so let's take a look at some code. So this is the MultiView demo that comes with RadStudio XE7. Here we see a form that has a MultiView control. And this is the MultiView control here. You see the MultiView, it's a container. In this case, it has a list box, which has a few items, and a toolbar that has a label. This is a fun demo to play with, and I definitely encourage you to play with it. The MultiView has different modes. By default, it's set to platform behavior mode, which determines how it's going to appear based on some platform metrics, and I'll show that in a little bit. But it basically has 3 built-in modes for appearance. It has a docked panel, which is what you see here. This is the appearance that will typically be shown on a tablet or desktop application. It has a popover. With popover, it has this button. It's called a master button. And that makes the panel pop up. And it has another mode called a drawer. Again, it uses the master button to slide out the drawer. And you can see here that it's overlaying the underlying content. You can change that mode so that it pushes instead. So now it pushes the content out of the way. I'm using a button here on the desktop, but it's also hooked up to gestures on mobile devices as well for sliding the drawer in and out. But those are the basic modes that we have defined. And each of these modes is what's called a presentation. If we look here in the Object Inspector, see there's a mode. We have it set to platform behavior by default. These are the modes that you can hard code if you want, or preset if you want. But each of those modes is a presentation. And a presentation, if we look at the code for the unit here, is an implementation of this abstract class, TMultiView presentation. And this presentation object defines what happens with the panel, how it appears. We have a method that defines which of these presentations is going to be used on the device, called define platform behavior. And if we look at the code for this, we see that we start with a default that it's going to be a dock panel. Then we call this behavior service to get the class of the device. If the device is a phone, then we want it to be a drawer class. If it's a tablet, we look to see if it's oriented portrait or landscape. If it's portrait or inverted portrait, then we're going to use a drawer presentation for it. If it's landscape or inverted landscape, we'll go to the dock panel presentation. This define platform behavior method is virtual. So if you make a custom subclass of TMultiView, you can override this selection. That's a little insight into kind of the magic of the MultiView and how it's able to work. And it's definitely worth some time going through this, because this control solves a lot of problems for being able to use one control, one set of APIs to control the navigation in your application, and it will appear differently at runtime depending on the available screen real estate. So in addition to new components and new platform behaviors, we've added some new platform services to the FireMonkey framework as well. We have a new save state service. This is exposed through the T custom form object through a save state property and an unsaved state event. And what this does is it makes it easy for you to be able to save the state of your application and save the state of a form. For mobile devices in particular, this is important, but it's also relevant on desktop, where you may want to retrieve the values that are saved in a form. Another platform service that we've introduced is called the IFMX logging service. And this provides a multi-platform abstraction of writing debug log output. It provides a method that takes a format string and a list of parameters. And on Windows, it shows it as an output debug string, so you will see it in the debugger. On iOS and macOS 10, it writes it to the console, so you can use the console applications to see the debug output. On Android, it writes it to the system log that you can view via ADB. This is really turning creating a service out of some functionality that we've used internally for a number of years. I think both of these are probably best shown through an example. So let's take a look at some code. So this is an application that has a form, a tab control, and there's a bit of data, a few controls that store data on each of the tabs of the tab control. On the form, we've implemented a couple events. We've implemented the form create event, and we've implemented this new onSaveState event. Let's take a look at the handler for the onSaveState event. This event will get fired on a desktop application. It gets fired when the form is destroyed, and on mobile applications, it gets fired when the form or the application is going to go into the background. This form save state gives you an opportunity to save things. So in this case, we're creating a binary writer. We're doing some tests to make sure that there's relevant data to save. If there is, then we write that data into the stream that's defined by the new save state property of the form. And in the form create, it's essentially the reverse. We call the save state property and see if it has a stream associated with it that has data in it. If it does, then we load that stream and we set the controls to have the values of that were saved in the stream. And the sample also shows the logging service as well. This item here, log.d, this would make a debug log entry. And in this case, I'm not really using a format string. I'm just putting a string with an empty set of parameters. Let's run this and we can see what this looks like. So here's an application that started up. And first I want to show you down here in the event log, this debug output, fresh startup. So that's what we had right here. This log produced this output. So let me put some data in here. And this is a memo control. And we can set some options here. Say set this one. And then let's just shut down the application. Now let's run it again. Okay, first down here in the debug, you see this output debug string recovering from previous state. And that is what we had right here in this log statement. So you can see that it has recovered the information. First, it shows the third tab, which is what was active when we closed the application. Look at the customer, it has this information. The memo has been populated. So this has restored the state into this temporary save state stream. So that's how some of these new properties and logging service allow you to save the state of an application and also write some debugging information in a much easier way. In Red Studio XE7, we've made a major architectural change to the TEdit controls. We've done this to separate the data model of the control from the view or presentation of the control. This makes it possible to use an actual native control to render and accept input. On iOS, it uses a UI text field. This is the latest and most complete incarnation of technology that we've been working on for several years. You've seen earlier versions of this in the native pickers that we use on iOS and Android, and in concept, much of the TMultiView uses a similar approach as well. With this architecture, you use the TEdit control as you always have. The properties, methods, and events are the same across all platforms. There's a new control type property, and you can use that to choose a native control for the platforms that support that. For all other platforms, the existing styled presentation will be used. The native presentation is only available on iOS and Rad Studio XE7. Let's take a look at some code. So here we have a form that has an edit control. If we look at the object inspector, you see that there's this new property, control type. By default, it's set to styled. We can change it to be a platform control type. And you see in the designer, the control has changed to outline. This lets you design your form around it. You can set the size of it, but we only show the outline to indicate that this is going to use a native presentation. If we look at the edit control itself, we see that TCustomEdit now descends from this new type, TPresented TPresented is declared in this unit FMX controls.presentation. And you see TPresented descends from TStyled control, and this is where the control type enumeration is declared. And you can see this is also where the model field exists. And we also have this field called presentation proxy. The presentation proxy is an object that handles the communication between the FireMonkey control and the presentation, whether it's the styled presentation or the native presentation. That proxy class is declared here. This is the TPresentation proxy. If we look at the data model itself, there's this unit FMX controls.model, and this defines the base TData model class. There's not a whole lot to this. For the edit control, there's a custom subclass of this, which is declared in FMX edit. This is the TCustomEdit model. It descends from TData model. And this defines essentially the properties that the model stores. This is the data model for the edit control. And what happens is the model can send messages to the presentation. And these constants define message IDs. So you have things like the selection start change, the selection length changed, whether it's read only, if it's a password. These are the messages that the model can send to the presentation. And if we look at the actual native implementation of the TEdit, we have this unit TIOS native edit. And you see this does use a UI text field on iOS. And you see that this mostly consists of message handling methods. So these are message handlers for the messages that we saw in the FMX edit. So that shows you a little bit about how this new architecture works. And it's implemented on the TEdit control for Rad Studio XE7. And the native presentation is provided for iOS, also in XE7. In the future, we would like to expand this to include more controls and more platforms. That's all the time that we have for today. I've shown you how FireMonkey makes multi-platform, multi-device development even easier by adding platform behaviors for size and position. I've shown you the variant of form inheritance that we call Delta Streams, which provides the power behind the Fire UI designer. I showed the TMultiView, our new super container component that makes it easy to write multi-platform navigation. The save state service that makes it easy to save the state of your application. And the logging service that makes it easy to write debug information in a platform-independent way. And I showed the new model view architecture of the TEdit control that makes it possible to use a native UI text field on iOS without giving up the multi-platform code compatibility of FireMonkey. Thanks for watching today.
How exactly does the mechanism work that uses native iOS components in FireMonkey? Does that happen automatically under the hood? And is there a list of components that are automatically translated to native iOS controls?
It is not automatic. You have to choose on the control that you want the platform presentation. For Rad Studio XE7, it is supported by the TEdit control. There's also some other controls that use a native presentation. The controls like the combo box, the picker controls like that, like the date time picker. Those use native controls on iOS. And again, those have a field for selecting the style. You can choose a styled presentation of it, or you can choose the platform presentation.
So the property is called presentation. It's either platform or styled. Is that right?
I think it varies a little bit between the controls. On the edit control, is called control type.
Okay.
One thing also is if you set the control type to use the native control, to use the platform control, and you run the application on another platform like Windows or Mac or Android, where we only have the styled control or the styled presentation, then it automatically falls back to the styled presentation. So that way you can get the advantages of the native control, but still have the cross-platform compatibility.
Oh, that's good. Is it possible to change the size of the components proportionally according to platform? Is it only possible through code?
No, you can resize it in the designer. You get an outline of the edit control, but you can resize it in the designer to be whatever size that you choose to.
Is there a way the new inheritance technology could one day allow new components in inherited streams versus having to hide subsets of shared components?
I suppose it's possible in the future that something like that could happen. By having multiple views of the same form, it is a bit different and distinct from form inheritance. So you can add components and hide them in views for different platforms. But as far as being able to add a new component that only exists on a certain view, the problem is that there's just one form class, and that form class has to be able to instantiate all the components. So at least for the foreseeable future, it's going to continue to share that one form class.
See, you could have a problem if you introduced two components on two different views that had the same name. That would create a conflict.
Exactly.
Yeah. What do we need to support iPhone 6 and 6 Plus?
There's nothing in particular that you need to support that. There are some changes that Apple has made to the size of the launch image or the splash screen, and So you have to be able to, if you don't set the size of that launch image correctly, then Apple will presume that you're running an application that's made for the iPhone 5, and it will scale the screen. And so that's true on both the iPhone 6 and the iPhone 6 Plus. We have some updates that are in the works that will automatically add the launch images of the correct size, and make a few little changes to the detection algorithm so that the 6 and 6 Plus are explicitly listed. But that's stuff that you can do by editing the info plist with the current shipping product. Will make it a lot easier to do with the update that's in the works.
Great. Did VFI see any improvements as a result of the Fire UI work?
There's probably been a few bugs that were fixed in it because the the form inheritance mechanism was exercised a lot more than what it has been in the past. But as far as particular new features that were added to it, no. But if there were issues or performance problems that we ran into, they may have been addressed.
Can we influence which resource is used on which device, or do we have to rely on the runtime to do it?
You really have to, for the most part, you rely on the runtime to do it. But if there is a specific device that you want, and this is probably particularly true on Android devices, if you really want to target one particular device, you can do that. I think we have an article posted online that shows you how to make a package for defining a custom device in the designer. And you can also do, you can register a custom device and give the exact dimensions of and specifications for the device that you want.
Yeah, I covered that in my session we just had a few hours ago.
Okay.
And there is an article online as well. And Bruce elaborated on his question about the VFI, and he said he was talking about bug fixes. So good.
Okay. Yeah, I don't know specifically if there were any issues that came up, but because we exercised that routine quite a bit, it's very likely that there may have been some issues addressed.
Is there a way of adding other controls to each list box item, for example, icons or more data fields?
For a list box, yes, you can. A list box item is a pretty flexible container control. You can add just about anything you want to. A list view is a little bit different. It's more restricted, and a list view item has less customizability, and that's a trade-off for the extra performance that you get out of a list view.
Okay. Are all FireMonkey controls for iOS now native, or just some of them?
Just some of them. For XE7, the pickers and the edit control are the ones that have a native presentation for them.
It appears that the save state process is saving the info to an external file. Is that correct, or is that an option?
That's an option. When you configure that, you essentially set up where you want to save the data.
Okay. What is recommended for new code for the way to override these MVC controls? For example, if I wanted to override the do change or change method of a TEdit, but not use the event in order to leave it open for the user, but it seems to require overriding the model and all of the platform TEdits to use my new model.
Well, if you want to make a presentation, a custom presentation of it, we have a mechanism for doing that. If you want to change the model itself, really the only way to do that would be by subclassing the model and overriding the methods that you want. But for the presentation, You can make something that descends off of the custom presentation class, and you can override the specific things that you want and then register that as a custom presentation.
Okay. So Troy has a comment here. He says, you save all the Delphi programmers a lot of time moving Delphi forward. Each new rev gets better and better. It's nice to see a great programmer talk about their work. So keep up the good work.
Great. We'll try to.
Do the native representations of a control only look and behave like a native control, or does it have the native field properties and events?
It is displayed using the, like for the edit, for example, it's displayed using the UI text field. So it uses the native control to render it on the screen, but the events still come through the TEdit control. So the events that are generated on the native control get mapped into events on the TEdit. So you would still implement event handlers for the TEdit.
Okay. So Walter, who asked about proportionally changing components earlier, he said that he was talking about as if you have a component that is 40 by 40 in Android, or in iOS it's 40 by 40, in Android it's 80 by 80. When you change to iOS to 50 by 50, in Android it should change to 100 by 100. So
there's not a way to do that automatically. You would have to do that on the custom views for each device.
Now I know we do have the proportional, the stretch view, or stretch layout, I think it's what's called.
Right, yeah.
So if you were to put your controls in that and then resize that layout, then that could, but you still have to write some code.
Right, yeah. Yeah, you probably have to write a little bit of code, but you could use something like that.
It always depends on exactly what you're trying to do. There's lots of ways to do things.
Yeah.
Are control methods going to support multi-platform in the future with automatic if-defing or something?
I'm not entirely sure what the question is.
I think he's referring to native controls, maybe. Native controls automatically.
Yeah, and well, in the future, we would like to support more platforms. We're supporting iOS with XE7. We would like to be able to do other platforms as well. And when we are able to support multiple platforms with the native presentations, there's not going to be any if-defing that should be required. That should all be handled automatically by the framework.
And here's it says, would like to have more programmers and internal engineers during Code Rage sessions. I really appreciate your session here. So
Sure.
I think that's it. If there's any other questions for Darren Kosinski, go ahead and put them in the question panel now and they go to webinar software. Otherwise, we'll take a little break here before our next session. Okay, it looks like that might be it for now. Darren, thank you so much for that great session. As always, I learned a lot as well.
Sure. Thank you.
Thank you.